Hello and welcome to week 11. I think it was 2 days ago, I was talking about week 10 and RAG. I think one of the slides on talk about DSPy. And not 2 days later, which is today, this morning and last night, DSPy got blown up on like Reddit and Twitter, wherever you like follow social media, because it has a security or a vulnerability in it. I believe it was Light LLM. It uses Light LLM, and Light LLM actually has a vulnerability in it. And it's just, I mean, it's literally getting blown up all over the internet. People are super worried about it. I was talking to a friend of mine at Databricks, and they're turning off a bunch of sandboxes. We've tried to insulate ourselves. Like, I don't use it in any of my production code or any of my dev environment, so I'm insulated there. I know other developers do. So, like I said, that is one of the hard issues with what we do with AI stuff. It's just a never-ending battle to try to stay up to date and try to stay, I guess, aware of things. I recorded this video a couple days ago, and my face and sound looked weird. If my sound is messed up, let me know, because I watched the video for like a couple minutes. I'd check out random places, and it looked good to me. But then when I actually opened it in Pento, whatever the program is, it was horrible. So I don't know what happened. So that's why I want to record the video again. The couple updates for those of you that were interested, and just in general, I'm teaching an AI in healthcare class this fall. Find it here. Do this. Okay, maybe it's just a temporary blip. So anyways, so we think about a RAG, and that's what we talked about yesterday. So really, when we think about it, what are we doing? We're adding chunks of information to help us answer a question. A lot of times there are sentence questions. We've had those classes where we've had to write something. Write a paragraph explaining X, Y, or Z, or write a paragraph on this, or um, John had 12 baskets. Blah blah blah. Use a formula to figure this out. Okay. That's where RAG, I think of it, it helps. To me, it's a cheat sheet. Okay, because you have a little piece of paper, you have a little chunk, and that's a technical term for it, a little chunk you're sending towards or to the LLM. The LLM will use that plus its knowledge. Cheat sheet, you use that cheat sheet plus your knowledge, your past courses, your ability to speak, your ability to write, in order to come up with a sentence, a solution. and that's great. Now, what is a LoRa? A low rank adapter, okay? So this kind of, in my mind, changes the output. Ragtime kind of changes the input. What if we change the output? What if we say it has to be A, B, C, or D? It makes it a lot easier. What if, you know, instead of starting a whole restaurant, we just buy McDonald's. It's already pretty much done. We just have to kind of follow the manual. We have to kind of follow the instructions. That's what LoRa is. So LoRa, we're not trying to change the input. We're basically freezing the weights. We're freezing the insides. And then we're just saying, hey, your output has to be like this. We're trying to just change the output. We're trying to change the end of it. And these have a lot of value. And I think they're highly underused. I don't think they're really documented enough. I don't, well, not documented. I don't think they're used enough in the world. Let me see if I can give you an example of that. So recently I went to a medical conference in November of last year, I think it was. And there were people talking about AI and LLMs and stuff like this. And I wasn't happy with some of the things they're saying. And for those of you who know me and that have worked with me, know that I will just start working and fixing something. I want to make it better. I want to make a change. And so that's what I did. I did not think I was going to be as successful as I was. So this is the number one, the best in the world embedding model for cardiology. And why did I not think this was going to be as good as it was? Because cardiology is the most expensive healthcare problem. Heart attacks, it's more expensive than cancer. So cardiology is a $400 billion problem each year. $400 billion problem. And I, just with a couple of computers I rented at Mass Compute, created the world's best embedding model. Okay. And so how did I create the world's best embedding model? Okay. Well, I took basically an embedding model, one that existed already, and I just threw a LoRa on. I trained a LoRa. I froze the weights and said, hey, let me just add a LoRa fine tune on top of it. It's this paper, sorry. Okay. So I just took Quinn 3 8 billion base and added a LoRa on top of it. And I compared it to fine-tuned models. I used medical benchmarks. So medical state-of-the-art medical models, general encoders, the Quinn base encoder, my encoder. So it works great. Now I have the world's best encoding model, or embedder, I should say, for cardiology. Okay, now, there is one problem. The LoRa's are specific to the model. If you freeze a model, it is particular to that model. If you freeze that model and you do weights and stuff, it's specific to that model, okay? I use Quinn 3 8 billion. I don't have access to that in my work. I didn't do this for my work. I did this just because it needed to be done. So then I created another paper where I trained a bunch of other LoRa's. And so this is a comparison of LoRa's for different models. So that way you can throw on Quinn 2.5, or you can throw on BGE, you can throw on all these different models, because that way you might have it at work. And we're seeing a 700% increase on the base model on the embedding. Some models do better, some models do worse. So if you have the Quinn 3 4 billion model and you use my LoRa on top of it at the end to force the output, you're getting about 1200%. Come on up here, Lucky. Somebody again wants to say hi in every video. Lucky wants to say hi. I think he wants to learn a little bit more about encoding or LoRa. Don't you, Lucky? Anyway, and that's amazing. So some little thing that took me a week or two, I can get a 1,200%, 1,500% increase in performance. And what does that mean in realistic terms? If you were doing a test and you could ask a book question, you have the textbook, you could ask it, and it would do a tenfold increase in accuracy when you asked it a question. That would be phenomenal. And to build upon that idea, cardiologists make a lot of money. I know a lot of cardiologists. I wish I made that type of money. Cardiologists make a lot of money. They can't afford to wait around. They can't afford inaccurate information, and they can't afford bad information. And this is the biggest expense in the American healthcare system. By just making simple LoRA, we can improve performance, tenfold, sevenfold overall in every model. But just think about that. That's something that we could do on a lot of businesses, a lot of domains, drugs, legal, all types of things. State jurisdiction. There's an amazing use of these LoRa's, and not a lot of people are using them. And it's kind of a shame. So let's dig in a little bit, and we'll explain a little bit more about what a LoRa is. A few other topics. I got a couple other things to go into first, but I just wish I could get rid of that. Oh well. So again, this was Gemini. Could be completely fake. Don't hold me to it. There are two types of companies in the world: those who are great at AI and those who are obsolete. Mark Cuban. Um, Artificial intelligence, deep learning, machine learning, whatever you're doing, if you don't understand it, learn it, because otherwise you'll be a dinosaur in 3 years. Okay, so we talked about chunking last week, and I just wanted to make sure that it explained chunking in terms of like RAG, and I found this graph, and it will help maybe explain a few things. Okay, so we have a document, and we can't send the whole document to LLM all at one time. So what we can do is we can break it up to chunks, 200 tokens. And here we're using 10%, and we overlap the front and end of it, and then we get this 240 token chunk that we can embed. And then when we search for a question, we hit basically that semantic database, and we look for that question. And then from there, we can augment it. We can send it to the LLM to help it understand our question, to help give it context. We talked about encoding. Encoding is just taking letters, A, B, C, D, and changing it to numbers. And here's a little bit better understanding, a little different diagram I have of a RAG. So query, what is synosis, blah, blah, blah. Okay, whatever question you want to add. It embeds basically the question. It goes to the vector store and look for this semantically similar questions or documents, not questions, documents, and then it grabs 2 or 3 of those top related documents right here, and then it packages them up. Kind of, I guess, weird way to think about it. Send it to an LM. So now the LM has your query and it has additional information, and boom, it can answer the question with more intelligence, with more context. Now, as I said last week, there's some very important, very actual good reasons to use LL or to use RAGs. Maybe you're doing something very specific that I don't say nobody else is doing, but that not everyone on the internet's doing. There's a good use to use a RAG. Not good uses when you're doing summarizing emails, looking for junk mail, when you're building Python code. Those are not good uses of RAGs. RAGs, you want something that's maybe not public information, that's your kind of domain knowledge. Okay. Now let's dig in, and we're going to go through this kind of fast because I want to get to the LoRa because that's what I'm passionate about. Okay. Um, and I talked about this a little bit last week, but output matters. When we do APIs or programmatically contact an LLM, and we want data back, we want it to be in certain formats. Okay. Here is a paper or some data, and here's the data I think that was related to it. And it's unusable. It is really unusable. because even if you see it, the way it's broken down and structured, it's just impossible. So when we do things, the output matters. How we store the output, how we get the output is important. Okay. I think I talked about in this class a while ago how books used to be taught right from corner to corner, no spaces, no breaks, no periods, no comma, just word after word after word. And it became computationally heavy to read. Then they added periods and they added returns, they added some space and they added paragraph breaks. That formatting helps us humans read a book. The same thing is true with LLMs. Now, again, hard to visualize, hard to conceptualize. So, JSON, let me just show you here real quick. This is kind of what JSON looks like. Okay. So, this is just, I don't even know what this one was. Read it here. I have another example of this too. But so JSON, we double quote, so bracket what it is, the category, I guess, or a key, the technical term, and the value. So this is basically how JSON looks. So it's nice because it's quoted, and so if I have colons in there, if I have things in there, I know where my JSON starts and stops. I know where my key stops and starts. I know where my results stop and start. Okay, and this becomes clearer when you see it a little bit more. Another example, same kind of information. You'll be so name Stanford, name MIT. You can see very clearly how it is. And if it was in text like this, it becomes harder to read, a little bit easier to read. So, I use curly brackets for the start and stop an object. So, another common one is YAML. YAML is used, it's kind of like, I guess, CSS. It's, used for the internet. It's used for human readability. It's, I use YAML, I use JSON. CSV, a lot of you know CSV. These are just different formats. Here's kind of the same thing. Name, University of Oxford. Name, University of Tokyo. What's the problem here? What if we have commas or returns or breaks in here? That's where sometimes some of this messes up. Okay. What I had, give me one sec. Oh, right here. Okay. We think about this. If I was to give you this, you can actually include the paste bin right here. I don't have a web browser open, but you can go to the web browser right now and look at it. If I say, hey, I need to know the average of the last 7 days of Alpha Tech stock price. Yeah, you could tell me, but it's computationally hard. You have to sort through that garbage. What's the first day you have stock of Alpha Tech and the last day? What are the 10 different companies you have here? I mean, we could do this as humans. It's not very fun. It's expensive in terms of our processing power. What if I give it to you like this? Oh, oh, Richard, look at that. Well, I can see price 105, price 106, price 108, price 107, price 109. My camera's covering the next one. So, average of 107-ish, 3 seconds I can do that. Same information is in here. Price 105, and I can see it right here. Price 108, same information. Very hard to read. So keep that in mind when we're working with LLMs and output, okay? And Pydantic is a tool that kind of forces things into those formats, okay? I've used Pydantic a lot. It works. It's just a tool that says, hey, then JSON, and it kind of verifies it. So RegEx, I just put out a paper on Monday where I look at output comparing regex as a judge, looking for quality, and an LLM, Claude Sonnet, I believe. Because if I was to give you a sentence, if I was to give you a phone number, how's that? Okay. So I go to the bar and I meet a lovely young lady, and, hey, she gives me her phone number and she writes it down on a piece of paper. Well, I know that it better have an area code. I think 3 digits and 4 digits, right? That's kind of how phone numbers go. Area code, 3 digits, another 3 digits, and then 4 digits. So if she hands me a phone number and it's incorrect, it's like 6 digits or something, or 12 digits, I know something's wrong. That's what regex is. Regex gives us the ability to look at text. Not very smart. Hey, are these letters? Hey, does this have 3 digits? D3. Hey, that might be an area code. Is it a capital A through Z? So if there's a 7 in here, not good. If there's a J in here, not good. And I can do an if-else statement. Hey, something's wrong. So if I have 5 million rows of phone numbers, I can quickly look over those 5 million rows of phone numbers and see what ones are valid phone numbers, what ones are invalid phone numbers. I can also ask Claude Sonnet to do the same thing, and we can compare the two. So for this class, regex is just simply a tool where you can get data, or not get data, you can go through data, regular expression, you can go through a lot of data quickly and validate its formatting. Social security numbers. Maybe you have a big chunk of text. This is something I do relatively commonly. Maybe you have a big chunk of text, hundreds of pages of, of calls or something else like that. And maybe you want to strip out social security numbers. Well, that's not super hard because now you know that social security numbers, the first 3 letters are like a state. So if you know all the first 3 letters, like, 530 or 525 or whatever they are, you could search for that in regex and then make sure that there's X number of numbers after that. 4, 7, whatever. So you look for the first 3 and you can limit those down to, whatever they are for social security numbers, and then make sure it has another, I don't know, 7 digits after it. Boom. You just solved how to get real social security numbers. So very good for looking at large quantities of data. So for like this, you could use regex, try to parse this out into a JSON. But if you just store it as JSON the first time, life will become a lot easier. Let's keep going down a little bit more. Trying to think. Okay. So if I don't know if I like this slide or not. If we think of LLMs, LLMs, and we've said this before, basically take text and turn it into numbers. Well, they group those numbers together to tokens. So LLMs are nothing more than mathematical engines. They strictly require numerical input. Our brains, the same thing. We fire these electrons in our brains and we weigh things and we just calculate probabilities. Now, I'm not going to go over a whole lot of the different types of encoding. We talked about this a couple weeks ago. Let me know if you have any questions. But at the end of the day, that's what encoding is. Let's see. Now, sentiment analysis. I know 2 or 3 students in this class are working on sentiment analysis, and it is a really great way to try to understand text. Matter of fact, a friend of mine, let me think how I can change this. He is just Googling, or he is parsing all the reviews on Google. So he's grabbing all the reviews on Google, and he's looking for a certain type of sentiment analysis. And then if he finds it, he's going to basically have somebody call that business and say, hey, this would do better. And this is not his area of expertise. He's not a salesman. He's a nerd like me. But so let's say I look at, let's say I Google all of the reviews today from, I go to Google and grab all the reviews, or Yelp or whatever. I grab all the reviews and I look for customers complaining that the restaurant is too hot or cold. This is not his business, but you guys could do this. And you find 10 reviews that say, hey, this restaurant was too hot. This restaurant was too cold. And you can use cinema analysis and look for people that are upset because the restaurant is too hot or too cold. Okay, well, so what do you do with that? Well, then you're maybe contracted with Sayer Air, or I don't know, Gaudi Air. I see those vans drive around, or whatever, air conditioning company. And then now you can contact that business as Gaudi Air or whatever and say, hey, I noticed on a few reviews today, I love your restaurant, by the way, but I noticed on a few reviews today, I went to review your restaurant, that people are having problems with hot or cold temperature, or that your restaurant's too hot or cold. Do you want me to come and check your ACL? I'll do it for free. And if something's broken, then you can sell it to them. Boom, instant business idea. Just sentiment analysis, reviews for a certain type of business, and then upsell them an idea on that service. Some sentiment analysis are, like we said, positive, negative, neutral. Some of them are happy, angry. Some of them are numbers. All different types of sentiment analysis. Some try to detect irony, sarcasm, and things like that. And it's hard because I, as a human, me particularly, have a hard time understanding sarcasm, irony, these emotional terms. I personally have a hard time. Some students understand it much better. Um, my wife can understand this. Not my thing. So I can't always understand. I can't always expect an LLM to understand. But you see, there's some clear examples on here. Dude, that movie was sick. Or negative. Negative's a great one. I forgot I added that one on. The patient is negative for cancer. Oh, that's horrible. Wait, no, that's great. You want to be negative for cancer. But how does a sentiment analysis analyze that? Negative is bad, but yet in this context it's good. The test results were negative for a broken bone. Oh, that's horrible. He doesn't have a broken bone. A regular sentiment analysis wouldn't work on that. So those are things to think about. And there's ways to come around that. And there's ways to solve that. And for those of you who are doing a few sentiment analysis on your Analyze Me, if you have questions, let me know. I'm going to grade it right after this lecture. Now, the prompting matrix. So this is the idea of, remember, we're not just sending one thing to an LLM. If we go back to those review things, how many reviews do you think Google businesses get a day? 10, 15, 100,000, a million? I mean, if I was to look, with all the zip codes in Las Vegas and grab all the Google reviews, how many do you think there are? I really, honestly have no idea, but 50,000 maybe? Do you think you can copy paste each one of those into Google? Boom, 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 boom. No, you have to programmatically do that. So I want you to keep that in your mind when we deal with some of these prompts, like some of the homeworks I've showed you. So, really, the two I want to talk about is zero-shot strategy. We don't give an example to the LLM. Hey, just tell me, summarize this into blah, blah, blah. Okay. Then there is few-shot strategies. And I believe there was a post on Reddit last month about how OpenAI engineers use few-shot strategies when they do programming. You get much, much better results. So, let me give you a concrete, clear, easy to understand example. You ready? If I was to say, hey, do an Analyze Me and I'll grade it, you guys would freak out. I'd be walking down the halls and you guys like, hey, what? And you throw apples at me or whatever students do, and it would not be pretty. I said, just give me an Analyze Me. It's worth half your grade. Give it to me in a week. Oh, you'll figure it out. You'd be pissed. You just would. I don't give you any direction. I don't give you any ideas because that Analyze Me is a complex task. I don't give you really ideas on the discussion homework. I give you a prompt, but I let you guys pretty much run wild because it's a paragraph reply. On the discussion, yeah, do what you want. I'm pretty liberal on that. But Analyze Me, I have structure. I'm looking for certain things. But what do I do to make you succeed as a student, as a friend? What do I do to help you succeed? I give you examples. If you go to Analyze Me, there's 4 or 5 examples. You can download them. You can look at them. Say, hey, this is what I need to do to complete this goal. So if it works for you as a human, why would it not work for an LLM? And surprise, it works for an LLM. Giving an LLM an example of what you're looking for can dramatically boost the accuracy of that. These are some different ideas of what LLMs can do. Prompting, and see, here's another thing that Gemini just failed on. So anyways, we talked about zero-shot encoding. No examples. Few-shot encoding is when you give it some examples. Hey, this is Analyze Me. This is what I'm looking for. Blah, do this. Chain of thought. Chain of thought's that little voice in your head that says, "Oh, let's see. to do the analyze me, I have to get references. Okay, I got to do that. Then after I get the references, I have to come up with data sets. Then after I get the data, I have to run some statistics. Maybe I should Google statistics. Maybe it's that little voice in your head that walks you through the steps you need to do to get things done. Yeah, I need to get to UNLV by 9 o'clock. So if I need to get to UNLV by 9 o'clock, I need to leave by 8. That means I need to get dressed by 7. Because I need to get gas in the car at 7:30, and maybe get breakfast at like 8:15 somewhere. So you start thinking about these steps you have to do. That's chain of thought reasoning. Machine learning models can do that too. So I think I have it in here. If not, some of the older models, ChatGPT 3.5, weren't. They didn't have reasoning. They didn't have chain of thought, so they couldn't do that. You ask them a question, and boom, they give you an answer. And for some things, that's better because it's faster. Now, my research last week, one of the papers I published last week was on chain of thought faithfulness. Does chain of thought portray truthfulness when you give it a hint, when you ask a question? Does it tell you the truth at the end of the day? And it surprisingly does not. Not very faithful. But we can talk about that later. So these are engineering techniques. Now also, you can give it a role. And I think, you know what, I did this. Let me see if I can find it. Okay, just looked, I do have it here, chat. Okay, so what we're doing, I got it on one machine, but not the other. Oh, that sucks. So give me 3 seconds, let me program this out for you guys. Then you can see it, that way you don't have to wait. Okay, so we're gonna ask the same model, but we're gonna change role, okay? Keep the English at an 8th grade or lower level. Make it very simple, very direct, no big words. Assume English may not be my first language. Keep the tone and response very, very simple. Okay, I think why this. And on here, somehow you can also show reasoning, enable reasoning. Then on here, keep it at a PhD or higher level. Assume I am an expert in English, and please use circumlocution and other multisyllable words to obfuscate, to obscure the true meaning of the reply. Whatever. Enable a reasoning. Okay, so hopefully it keeps that in memory. So now we can just ask it a question and see the difference. So this is just changing role. Same model, same everything. We're just going to change the role. Let's think of a question. I'm so out of questions today. See what happens when I do videos at the end of the day. Can you explain to me how or what a token is in relation to large language models, why they're important? Recently, I was watching a video and they said tokens are the economical force of LLMs in the future. I don't understand. Can you help me? Okay, so same model, same everything. And we're just changing the role. And so the role, if you remember, if I go back here to PowerPoint, role is right here, okay? That's a great question, and it's clear the video you watched had a small simple word saying economic instead of more standard terms like economic factor or cost driver. That's kind of complex, to be honest with you. Okay, so now let's try the other one of the reasoning, and then maybe I should add, okay, a token is a chunk of text. Words not very, did it not keep the, there we go. Okay, there we go. Can you explain to me why Paris is the capital of France? You use open web router Open Web UI. It puts them next to each other, which I like a little bit better. Actually, you know what? I should turn off reasoning. Huh. That will solve my problem. What is Schrodinger's cat problem? Okay. That's an excellent question and one of the most famous thought experiments in physics. But it's important to know up front, Schrodinger's cat isn't actually about cats being both dead and alive in reality. It was designed to, or went to, highlight a problem. Okay, so relatively easy to read. Let's see about this other one here down here. Schrodinger's, so again, now it gives us Austrian physicist Edward Schrödinger, 1935. It doesn't say anything about the cat really being alive or dead. It gives us a completely different answer. And so if you guys have access to Open Router, which I think most of you do, you can literally just go add model, and, pick the model, it again, and add model. Like I said, Open Web Router can kind of do this side by side. You can pick a free model. It doesn't really matter. Can you provide the answer in Pig Latin? I guess that would work. I never really tried it. Oops. Please make this at a graduate or higher level. Please use the exact words and do not reduce words and make it as complex as humanly possible. What is the difference between a poem and a haiku? So there's your reasoning tokens. Oh, so it's answering all the questions at the same time. Again, like I said, I don't normally use chat on Open Router. Oh, I have Open Web UI, and I mean, look at the difference here. Much different answer. A token is a basic unit that a language model processes. Okay, so again, then here, much more technical understanding. So that's what I'm talking about when I talk about role. Okay, close that out. Close that out. Format constraints. We talked about this a little bit. Hey, give me the output as a JSON. Give me as a markdown. Blah blah blah. On the last demo that died, I showed you on here where I use voice on Google and it can't make a markdown, but if I ask it in regular ChatGPT, it can make a markdown file. Remember that depending on how the format you use, the interface incoming dictates how the output would be. So if you've seen this, hey chat, can you make a Word document? I want to grade my students and I just need a overall grade, midterm, and final grade. Can you make a Word document for that?
Able to direct create or save Word for you, but I can help you structure the provide a template copy into Word.
Okay, so now I get out of that and I start a new chat, a blank chat. Can you create a Word document with overall grade, midterm, and final for me? And I just type it in. It's so hard to see on the phone. I'm sorry. It's so ghetto. And it will actually create a Word document that I can download. And so when we use different, yeah, see right here, download Word document. Yeah, and then it just opens up. Where it went to. There you go. So depending on the format we use, it really can depend on the output. So if we use an API, we tell it, hey, in Pydantic and other things, I want JSON, I want YAML, I want Markdown, I want CSS, these formats. Okay. So just keep that in mind. Now shifting the output, as I showed you with the role, we can change that. Now, why is that important? there's a study somewhere that something like 30 or 50% of patients don't understand their diagnosis leaving the hospital. And think about that. So, if we're trying to make the world a better place, we think we'd like to understand what's going on. So, when you buy a car, like you go down to Ford or Chevy and buy a car, do you really understand the contract? Do you understand the terms of the lease? Do you understand everything? Probably not. But what if we took that contract, put in an LLM, and say, hey, can you explain this to a nerd like Professor Young? Can you explain this to an accountant? Can you explain this to an engineer or CS person? Can you explain it to a person maybe that doesn't have a college education? Can you use analogies that this person would understand? So we can shift the outcome, make it much more viable. And this is a very, very important goal or tool that LLMs are very, very good at. Okay, because again, what's the difference between I guess what is it, VHS and beta? Well, I'll tell you, VHS just had better communication. Beta is a better technology. VHS is. If you look through the history of technology, same thing. A lot of technologies didn't win because they were better technologies. A lot of technologies won because they could shift the output of their product and relate to that consumer. Here's an example I used a while ago. Do some simple text, well, now make it completely, incredibly hard to read and make it easy, blah, blah. So we went over role prompting. That was that demo. One thing that a lot of programmers use is, hey, please review my code as a senior AI engineer, or you are a senior machine learning programmer with 20 years of experience. Please review my code, find any errors or ways I can make this better. Or, hey, you're a PhD student with 10 years of graduate writing. Please review my thesis, whatever you want to say, and it does make a huge difference. Okay, multi-agent systems and prompts. We're going to talk about this a little bit in, I think 2 weeks, maybe 3 weeks. This is one of the things that is relatively new. We can call these functions in OpenAI. We can call these tool calling in Quinn or Claude. But this is a really big issue right now, is multi-system prompting to do more than just one thing. You can ask an LLM a very general question like Mantis. Mantis, I think, was recently bought by Facebook. But you say, hey, Mantis, I need a PowerPoint on the animals of the jungle. Okay, just give me a PowerPoint, make a PowerPoint of all the top 10 animals of the jungle. So one tool will have to go out to the internet, and research. Another tool will actually have to load PowerPoint. Another tool will have to look at fonts and colors. Another tool will have to get images. So this multi-tool calling is a relatively new idea, but it's super important. Blah, 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 blah. Okay, so let's talk about the fun stuff. What are we at? Oh, 43 minutes. Good. So when we talk about fine tuning, okay, and let's just think about this as humans, okay? I know there's probably better. I know there's better. I can think we go to better ways, but there we go. Okay, so um, what is fine tuning? Fine tuning is changing all the weights on here. It is like changing all the neurons throughout the brain. Okay. Now, Richard, I don't know what that means. I don't know. I don't have access to $100,000 worth of video cards to do that. What if I asked you, forget everything you know about English and let's teach you Chinese for those students that don't speak Chinese? Very hard. Or what if I say, hey, don't speak English or Chinese, let's learn German. I want you to not use English, use German. A lot of work to learn a new language. And not only be able to speak it fluently, I want you to be able to read and write it. That requires a lot of work. Requires a lot of work. Well, what if I was just to give you a cheat sheet, that could be a rag, And when people say X in English, it means Y in German. I don't know how many people speak German in this class. I don't. That's a lot quicker. Or even better, LoRA, when somebody says this, it means this. Okay. And we'll get into some examples because LoRA has become more and more important, especially in visual models. As you say, training the whole model, it probably costs more than 50K in H100s. Okay, it costs a lot of money. So if we think of a LLM, a neural network, as a bunch of weights that have a bias, a number, I guess, a way to kind of change it. Um, Change all those biases, to change all those matrices is very expensive. Okay. And it requires specialized hardware, it requires time. That's a huge one. Even if you have the money, it's a lot of work. Okay. The So the analogy on here is great. So instead of remodeling the entire house, so let's say that you have a thermometer and your house is too hot or too cold. So instead of remodeling the whole house, what if you just wire a smart thermometer in there? Requires a lot less work. And a smart thermometer knows the temperature you want it set at. You're just kind of changing the output. Okay. So, we basically freeze all the weights and we just train the small end of it. We just train the attention layers. 1 to maybe 5, 1% of parameter. We train a very small amount of it. It's quick, it's fast, it works relatively well. Not perfect, but it works well. So that paper, the LoRa paper, I used Quinn 3 8 billion. So it's not even a state-of-the-art model. 3 billion, or sorry, an 8 billion parameter model, and not an embedding model, but just a regular 8 billion parameter model is relatively small. They're not really super. I don't want to say they're not super useful. That's not fair. But most of the new models, I mean, DeepSeek 671 billion parameters. So we think about these models, and 8 billion is a relatively small parameter model. Okay, so it's just small. I mean, it's something that you generally would not use. But so to fine tune a full 7 billion model parameter takes 120 gigs of VRAM. Now that blows through your RTX 6000, which is a $10,000 card. That blows through an A100, which is $30,000 to $80,000. You're looking at some of the high-end video cards from NVIDIA. We're talking, you know, cards that are upward to, I don't know, 100 grand, 200 grand for the video card. To train a really kind of small model. Then, if we want to use a LoRa, we freeze away, just train a small percentage of it, 16 gigs of VRAM. So that's just your 3070s, 4070s. Those are your consumer video cards. Go down to Best Buy and buy one of those today and put it on a credit card, and you're out maybe $1,000. Businesses can do that. I go to any restaurant, most restaurants, most janitorial shops, they can go out and buy a card to do a LoRa for things. They can't do it for full fine tuning. That shows you the power of LoRa. And then quantized LoRa. So quantization is the idea. Remember, I think I used a GPS example where instead of having these big, long series of numbers, we can kind of concatenate. We can kind of trim off the long numbers and just use a little bit less of the long numbers. Maybe instead of using 16 bits, we use 8 bits. So maybe, I'm in Nevada, you're in Nevada. Instead of giving 702, 1, 2, 3, 4, 5, 6, 7, 8, I just say, hey, my number is 1, 2, 3, 4, 5, 6, 7, 8. At UNLV, a lot of people just give the last 5 digits of their code, of their phone number. Because since they're on UNLV, they just tile that number in and boom, it works. Okay? That's quantization. And with quantization, it's 6 gigs. Dude, you could almost do that with like an iPhone or an iPad. Take something that's inaccessible to most small businesses, most medium-sized businesses, most people, full fine tuning, and you using tools and math and smart methods, you can do it on an iPhone basically. So some of the pros and cons. Massive, full fine tuning is massive, 100 plus gig, sometimes more. I mean, sometimes we're talking multiple clusters with multiple video cards. and you get one monolithic heavy model, but it's optimized under heavy loads. It has deep fundamental reasoning shifts because, again, if you train yourself to speak in German, maybe you think in German, but you fundamentally change how the model operates, and you might degrade performance. A LoRA, much faster. It's very highly algebra. It doesn't work, you retrain it. It doesn't work, you retrain it. And the training takes a day, you know. But now it can degrade under large batch nodes or loads. Well, you can scale it, but that's kind of not really a big issue. And dimensions can degrade after, pre-training knowledge. Yeah, that's true. And there is a paper on this, and it's a really great paper. I can link to it if you want. But and this just deals with reward methods. Okay, and I guess for the most part for this class, the takeaway, the important part is that DeepSeek fundamentally changed how we do rewards. Okay, so what do I mean by rewards? So, okay, how do we train an LLM? And this is not an engineering class. I don't want you to know the engineering side of this, but and I'm thinking, okay, so if we give an LLM a question, we have to create a rubric to grade that question. That's computationally expensive. We also have to have multiple graders grade it to ensure, I guess, fairness. That works. Okay, so we do that, and it's computationally expensive. Now, what if we do something a little bit different? What if we just say, we grade on a curve? It doesn't necessarily matter if you're right or wrong, not necessarily accurate, but we just mostly care about grading on a curve. So the most accurate, even if it's not 100% accurate, or even if it's not right, we'll give you a reward, and everyone else we won't. Now, what's the advantage of that? Because when we do the second pass, you get slightly better. Why? Because again, you have 5 people or 5, I guess, answers, and you're just grading on a curve. You grade on a curve. This is one of the things that DeepSeek introduced in their training, in their group policy method of training. Okay, so that has been a kind of a paradigm shift, and there's even kind of a newer one on this. When we talk about reinforcement learning, just know that we're talking one LLM asking another LLM question, or sometimes multiple LLMs asking each other questions, and to grade each other. And there's different ways to do it. Some are better than others. Because again, if I have a LoRA and I'm trying to train a LoRA, which we'll show you in a little bit, how do I know it's doing its job? Do it by asking another LLM. Now, I put this model on here because for a very specific reason. Let's see where we at here. Sorry. That's Safari. I actually got Safari to work. Trying to get back to Chrome. Okay, how many of you have seen these? A Reface, I think one on the iPhone. They have other things like this. Um, how does this work? So let's think about how this works. So to train an LLM would be thousands of images. Uh, how many images to train? I don't know, Black Forest Labs, Flux. Full model. I see they're just talking about LoRa's, but I believe, somebody told me it was over 1 million images to train. I don't know if it's Flux or what it was. Um, you think about that, I mean, full data set. Yeah, so there's no way that we can get like 12 million images of a single person. Well, we might be able to, but you know what I'm saying? You know, millions of images is not practical. How does this work? Well, what if we freeze that vision model? What if we freeze that vision model and then we have to upload a few images and we say, hey, this is kind of what we want. This is the output we want. And we just figure out the weights from the frozen model and just kind of make an adapter on the end of it. This is the input from the model, from the vision model. This is our, adapter. This is our LoRA, low rank adapter. And this is the output we want. And we just kind of train it that way. Output, freeze. So this is X. So 5 times what's 25. I mean, this class can solve that. And you can work backwards, and well, that's what we do here. This is the pictures uploaded by user. This is a model. I don't know, Flux or Stable Diffusion, or it doesn't matter, SD. And that's how we make a LoRA, a vision LoRA, for example. That's how we make a cardiology model. That's how I do it. A little different, but same basic idea. So now you're seeing that. Now let's before we go too far, let me see where I got for my slides. What's next here? Blah blah. There's different types of genetic. Actually, look, that's the last one. Awesome. Okay, so do you need to inject new real-time facts? Yes, use RAG. You need to consistent JSON, JPEG format. Yeah, use prompt engineering. You need to teach it a completely new specialized domain language or pictures, pathology, LoRA. Do you have a 50,000 K budget and need to fundamentally shift the core reasoning, fine tuning? Okay, so and it's much more than 50,000. Okay, so now let me see if I can find something on Hugging Face. Okay, so this is how parameter efficient fine tuning. This is kind of how it works more in detail. And the detail doesn't matter. At the end of the day, basis, LoRA. I had a couple really good ones when I did the last video. It doesn't really matter. So, how to do a LoRA? If you're interested, Llama Factory, I think it's one. Literally, you can just upload text and pick a model and have it start training. There is way to do vision LoRa's. There's ways to do text LoRa's. Hugging Face has Hugging Face LoRA pipeline. A lot of it's built into Hugging Face. Like I said, the reasons for it would be, hey, you have a model and you want to train it to do something very specific. You have a model and you want to teach it to do something very specific. A llama, legal. This is probably some type of LoRa trained right here. An AI turns structured probably concept of information. I cannot talk today. LoRa jokes. Maybe you want to have an LM tell jokes. There's none of those. LoRa. I think there's a romance one on here that's supposed to tell like love stories a little bit more. And medical questions. So here's one that's supposed to be better at medical question database. What they did is they took the original Nemo um, LLM and they found a bunch of medical questions and they put an adapter at the end of it. It's better at understanding medical questions. So again, I know it's kind of nebulous and it's hard because with LoRa's, until you actually do it, it's hard to understand the impact they'll have. But they're very important. Like I said, that's kind of the three ways you can do things. You can do a RAG, you can do a fine tuning, you can do a LoRa. There's a few others, and there's things in between the two, but that's really the concept of fine tuning here. And why is it important? Again, you know, you have a business that does something specialized, and maybe a normal LLM can do it, maybe a normal LLM can't. And that's a decision that you're just going to have to test. I ran an experiment today at work, looking at different three different LLMs to see how they answer a question. And I can tell you I got better answers than I did, but I didn't because one of them answered some questions really well, another LLM answered questions really well another way. So I'm back at square one. One of them was like 3 times faster. The other one was, you know, about twice as accurate on certain things. If you ask about ID cards, you know how insurance companies have ID cards. One LLM would do really well. You asked it about complaints, another LLM would do really well. And I tested 3 of them, so it's not a clear winner. So that's a problem for tomorrow. Because once I know what LLM is kind of the best, then I can build a LoRa on top of it. I can fine tune. I can do something new and different with it. I have to know a good base model, and then I have to take it to the next level. So let me know if you have any questions. Otherwise, have a great day.